Hey y'all, this is a continuation of Module 1.3. We're going to talk a little bit more about describing the transformation when you have an equation and have to tell what's happening using your words. So this says describe the transformation in words shown by the equations. I have my first equation, which is f of x equals x squared. It has been transformed into g of x equals x minus 5 squared plus 2. Now I can see that I have two things happening here. I have a plus 2 outside the parentheses, and I have a minus 5 inside. So I'm going to use my words to describe that. Now the plus 2, I know when I'm adding outside, means that I have moved this graph up 2 units. Anytime I'm adding or subtracting outside of the parentheses, the brackets, the square root, the exponent, whatever, I am moving the graph up or down. Inside the parentheses, or brackets or exponent or whatever, tells me that I'm moving it left and right, and it's always the opposite. So because I have a minus 5, I know that I have moved this graph to the right 5 units. So I'm kind of just breaking down that second equation, what all is happening here, what are the numbers that are different, and then working from there to figure out where they're positioned and how that graph has been transformed. Again, describe the transformation in words shown by the equations here. I'm starting with simply a 3 to the x power. And now over here on this G1, I'm transforming into a lot of different stuff. I have a minus 7. I have a 1/2 multiplier. The minus 7, again, it's being subtracted outside of the exponent. So I know that I have moved this down 7 units. Again, remember adding or subtracting outside the parentheses, outside the exponent, outside the radical, outside the brackets means that I'm moving my graph up and down. I'm not moving it left or right because I don't have anything with that x in the exponent. What I do have is a multiplier out front, which is less than 1. So my graph is actually shrinking vertically. So I'm going to say that I have a vertical shrink, and it is generally okay to abbreviate that, of 2. What I'm doing is I'm shrinking it by 2 units, or I'm cutting it in half, okay? So my vertical shrink of 2 is because I am cutting it in half. Kind of think about that. That's sort of a backwards way of talking about it. If it makes sense, I'm stretching it in half, which is kind of weird to think about because that's not actually a stretch, right? It's a shrink. I'm shrinking it by 2. It's becoming 2 times shorter than it was before. So I have a vertical shrink of 2 units here, even though it's 1/2 that's in front. I know it's a shrink. If it was 1/3 in front, I'd be shrinking it by 3. If it was 1/5, I'd be shrinking it by 5, etc. Okay? Here I am going to describe the transformation in words again, shown by the equations. I have an absolute value parent graph. I'm transforming it over here, and I'm doing 3 different things. I'm multiplying by 4, I'm adding 1 inside the brackets, and I'm subtracting 8 outside. I'm going to start with the subtracting 8, and I'm going to kind of work my way backwards. So subtracting 8, I know means that I have moved this down 8 units. Anytime I'm adding or subtracting outside the brackets, I'm up or down. Inside the brackets is left or right. And because this is a +1, I know that I have moved the graph left 1 unit. Remember that it's always the opposite. Plus is left, minus is right. Now to get to the 4, this is a multiplier, and because it's bigger than 1, it's a stretch. So I have a vertical stretch of 4. So this time I've done 3 different things. I've taken that original parent graph of the absolute value of x, I've moved it down 8 units, I've moved it left 1 unit, and I've stretched it vertically by 4. Thank goodness I don't have to actually graph that because that's a lot of movement, that's a lot of changes. So we're kind of just looking at the original equation, seeing what's been added or subtracted, where it's been positioned, and then using that to describe the transformation in words. In words means down or up, left or right, vertical stretch, vertical shrink, flip, whatever. You're using your words to describe what's happening, what those numbers are doing. We've got one more here. We've got an x cubed this time. So we're starting out with a cubic and we are doing a whole bunch of stuff to it, okay? We're adding 6 outside, which means that we have moved the graph up 6 units. We are adding 4 inside, which means we've moved the graph left 4 units. And then I'm multiplying 1/3, which means that I have shrunk, or I have a vertical shrink by 3. I've made it 3 times shorter because I've cut it in 1/3, okay? Notice each time I do this, I'm kind of starting at the far right and I'm working my way back into the parentheses. You don't have to do it this way, but I kind of like to deal with the up and down first, then the left or right, then the shrink or stretch, and a flip if there is one, okay? If you can organize yourself so that you're doing the same process every time, it will be much easier to remember where numbers are positioned and get them correct when you're describing what's happening. If you just look at that, it can be a little overwhelming because there's a lot happening here. You can see I've circled a bunch of different things, but if I start at the right and I start with my up or down, if there's not one there, then I haven't moved it up or down. Then I move into the brackets or parentheses, left or right. If there's not something there, then I haven't moved it. Then I move in front of the parentheses, shrink or stretch. And then I see if there's a negative for a flip. I'm kind of following the same process every single time. That helps keep me organized so I can make sure that I'm getting my descriptions correct. Hopefully this helped you kind of learn a little bit more about how to describe a function, looking at always the parent graph and then seeing what's being done to it and describing it again in words, meaning up or down, left or right, shrink or stretch, and flip, okay? As always, if you have any questions, let us know, send an email, stop by and ask. We're more than happy to help, and we hope that this makes some sense to you. Have fun doing some math. Hope you're enjoying your transforming equations.